participants for the Technical Parallel Session 3 on Computing of Annual International Research Conference of General Sir John Kotalawala Defense University. Now, you are here with us in the technical session, which is based on the theme of natural language processing applications for sustainable national growth. This session will be chaired by Professor RMVD Rathnayake from Department of Physical Sciences and Technology from Faculty of Applied Sciences of Sabaragama University of Sri Lanka, while the president will be Mr. M.W.P. Maduranga from Department of Computer Engineering of Faculty of Computing of General Sir John Kotalawala Defense University. Ladies and gentlemen, prior to the commencement of this session, I would like to invite Mr. M.W.P. Maduranga to give you a brief introduction on our chairperson. Over to you, sir.
Good afternoon, ladies and gentlemen. On behalf of Faculty of Computing, I welcome you all for the technical session 3 of the 15th International Research Conference of the Faculty of Computing, General Sir John Kotalawala Defense University. The technical session will be chaired by Professor RMVD Rathnayake from Sabaragama University of Sri Lanka. Professor RMVD Rathnayake presently working as a professor in statistics, Faculty of Applied Sciences, Sabaragama University of Sri Lanka. He has obtained his BSc special degree in mathematics and statistics from University of Ruhuna, Sri Lanka, with the first class honors. And he has obtained his master degree in industrial mathematics from the University of Sri Jayawardenepura, and he awarded the Chinese government scholarship for his second master degree in statistics. He received numbers of prestigious international awards, including Chinese Scholarship Award for Outstanding Students of the Year 2014, Outstanding Graduate Student of the Year in 2013. Furthermore, he nominated again for the Chinese Scholarship for Doctoral Degree in Applied Statistics in 2013. Furthermore, he has awarded Outstanding Junior Researcher in 2020 in the 25th of anniversary ceremony, Sabaragama University of Sri Lanka. Moreover, he has awarded Best Researcher 2021 award for the Faculty of Applied Sciences 26th Annual Day Celebration, Sabaragama University of Sri Lanka. Currently, he involved in multidisciplinary applied research with specific focus on economics, financial, and biostatistics. Additionally, he is very conversed in data analyzing under different practical scenarios based on the tradition and novel introduced statistical approaches. He has published his work in several reputed international journals, such as Journal of Gray Systems, Theory and Application, Emerald Insight, and Modern Economy and Economy. So I cordially invite Professor Rathnayake to chair the session. Over to you, sir.
Okay, thank you very much, all of you. Good afternoon. First of all, I need to thank KDU for inviting me, especially conducting this session. Also, we need to thank KDU, especially arranging like a research conference annually. This is a great honor, as well as this is a great opportunity for our young research students to show their research findings. Okay, without taking much time, we will move to our session because we are fighting time. Okay, so first author is Shelantha Silva. Shelantha Silva is the undergraduate at same university, General Sri John Kotalawala Defense University, following BSc Honors degree in Computer Engineering. She is also SIMA pass finalist. So I cordially invite Shelantha Silva to present the presentation. Okay, so Shelantha, this time for you.
Good afternoon, everyone. My name is Shelantha Silva, and today I'm going to be presenting on my project, a self-monitoring system for online education. To start off, let me talk about the research problem that was tackled by my project. Accelerated by the COVID-19 global pandemic, online education has overtaken traditional classroom learning as students' preferred form of learning. To quote a statistic on this matter, by 2026, The global e-learning industry is projected to reach 336 billion. However, e-learning is obviously not without its challenges. In fact, if we delve deeper into the statistics, we can actually see that e-learning has resulted in students' grade point average reducing by a certain amount. This may be because traditional teaching is bidirectional, but online learning has become more unidirectional. What this means is that in a classroom, for example, a student is forced to pay attention to the teacher as the teacher may ask questions. Furthermore, if the student's attention is not properly focused on what the teacher is teaching, the other students may also notice. However, in comparison, online learning lacks that creativity. As you can see by that picture, it is completely possible for a student to log into their lecture and afterwards just fall asleep. In that sense, online learning may impede self-motivation and affect students' concentration. However, this may result in the student not learning at an adequate pace. If I move on to the proposed solution to this problem, it is a self-monitoring system that will assist in carrying out online education. The system will be developed to follow the guidelines of the Buddhist philosophy of Iddhipada and will monitor students and provide helpful suggestions for them to have increased levels of interest and dedication towards their studies and maintain high levels of concentration and motivation. So as I mentioned before, the guiding principle behind the proposed self-monitoring system is a Buddhist philosophy by the name of Iddhipada. This philosophy highlights 4 bases of spirituality that can be considered when undertaking any task. The 4 bases are Chanda, Chitta, Virya, and Vimansa. Basically, to explain this in common terms, Chanda means intention and interest. Chitta means positive mindset. Virya means effort and perseverance. And Vimansa means curiosity and an investigative nature. The goal of the system is to create a learning space that will foster all 4 of these, that is interest, positive mindset, perseverance, and a curious mind in equal amounts. If all 4 of these are present in equal and adequate amounts, it can contribute greatly towards any learning task being successful. Obviously, that does not mean that this is the only factor that you need for learning to be successful. However, maintaining all 4 of these in adequate amounts may contribute greatly. Before I started on my project, first I carried out a thorough critical review of existing systems. First of all, I studied on existing learning management systems. If I highlight the main learning management systems here, the first one would be Moodle. As we know, Moodle is very familiar to all of us. And some of the features of the Moodle are that it is open source, it is easily customizable, widely available, and very familiar. However, the Moodle comes with certain limitations. It is not fully developed to cope with a large load of students. The more students that access the platform, the slower it becomes. Secondly, MindFlash is also very popular. Its features include facilitating creating training courses within minutes, robust learning experiences for users, and easy-to-use interfaces. It is also scalable. Its limitations are that it has no ready-made template and it has limited styles for quizzes. Thirdly, if we touch on ProProf's LMS, its features are that it centrally administers learning, it makes announcements and views reports. However, its limitations are that no identity verification for exams can take place. Moving on, I also studied on very popular existing meeting platforms. As we all know, the most popular out of these 3 are Google Meet, Microsoft Teams, and Zoom. If I touch quickly on some of their features, Google Meet has features such as noise cancellation, up to 250 attendees, meeting videos saved to Google Drive, and strong security features. However, Google Meet may be difficult in integrating with other third-party platforms. To touch quickly on Microsoft Team features, it's easy to schedule meetings through Outlook calendar. You can record meetings, you can have virtual backgrounds, shared whiteboards, and breakout rooms. However, Microsoft Teams may not be very user-friendly for new users. And lastly, to touch quickly on Zoom, Zoom has features such as whiteboards, breakout rooms, virtual backgrounds, Snapchat-style filters, and reports. However, it also has limited storage capacity and it must be downloaded to be used. Lastly, I also did a literature review on existing emotion recognition systems. As you can see, I have highlighted and tabulated some of my findings, including some of the most popular emotion recognition systems. They use features such as the HAR cascade algorithm, the AWS learning algorithm, the hidden Markov model, and support vector machine. I unfortunately cannot delve deeper into this due to the time constraint. So if I move on, during my critical review of all the existing systems, I discovered a gap in literature as follows. Most existing systems have no founding principle behind their development. In addition, existing systems have no monitoring aspect, which can lead to loss of concentration in a student. Student activities are not tracked in existing systems, and they may be distracted frequently while engaging in studies. Also, questions are generated randomly and do not focus on students' specific needs. So if I move on to my system now, this is its top-level architecture. It has 4 modules in terms of the chatbot interface, teaching system, knowledge base, and monitoring system. As you can see, the user interacts with the teaching system via the chatbot interface. There is also a knowledge base, that is the database that stores all the information related to the teaching system. And you also have a monitoring system. Let me expand a little on the monitoring system. Basically, monitoring is carried out in 3 different ways. First of all, you monitor the emotions of the student to see if the student is sleepy, sad, angry, neutral, or happy. In addition to that, you can also monitor activity of the students, such as mouse movements and time elapsed. Also, the final type of monitoring will be the Irdipada-based monitoring, which monitors the 4 bases, Chanda, Chitta, Virya, and Vimansa. If we move on to the technology I used in my system, I used Java as the coding base, PHP MySQL was the database, Python TensorFlow was used to train the emotion recognition model, and AI/ML is what I use for the chatbot. Let me quickly touch on the special features of the proposed system. First of all, it has a strong guiding philosophy behind it, that is the Buddhist philosophy of Irdipada. In addition, it has monitoring aspects, unlike other learning platforms, and the student is periodically monitored by the system in 2 ways. The student's emotions are monitored and helpful suggestions are provided. Also, the student's activities are monitored, such as mouse movements, time taken to complete quizzes, etc. Also, the questions in quizzes are predefined and based on the Irdipada principle and geared towards maintaining all 4 in equal and adequate levels. So this is the basic UI design of my system. If we move on to the implementation, as you can see, the system has 3 main parts. First of all, the student's emotions are monitored. For example, we check if the student is sleepy or happy or sad, and based on that, the system will provide recommendations on how to improve the student's emotional state. Secondly, the student's activities are monitored, such as mouse movements, the time taken to complete questions, etc. And finally, we also monitor the 4 Irdipada bases. As you can see, there is a graph there to monitor the 4 bases, Chanda, Chitta, Virya, Vimansa, and the questions in the quizzes are predefined based on this Irdipada principle and geared towards maintaining all 4 in equal levels. Let me delve a little deeper into emotion and activity monitoring. Basically, emotion recognition model is trained to identify 5 classes of emotions, that is happy, sad, angry, neutral, and surprise. Training is done using the dataset FER 2013. A 200 by 200 image will be captured, converted to grayscale, and then used to recognize the student's emotional state. If we consider the neural network of this system, it will have 1 neuron in its input layer and 5 neurons in its output layer to represent the 5 classes of emotions. Activity monitoring, as I mentioned before, involves tracking the students' mouse movements and the time taken by students to answer quiz questions. So let me quickly move on to the question style. As you can see, each of the questions, here we have 20 sample questions that I have designed. Each of the questions is given a weightage to a particular Irrithipada base. For example, the first 5 lot of questions have been given a weightage towards the Chitta base. The second 5 have been given a weightage towards the Chanda base, and so on for the next 5 for the Virya base, and finally the next 5 for the Vimansa base. To explain this a little more clearly, I will use this slide. As you can see, there is an example question given there. That example question carries a Chitta value of 3 as shown in the table. So basically, if the student answers this question incorrectly, the total positive mindset, that is the Chitta value of the student, will reduce by 3 points. However, and the student will receive more questions that have a higher weightage for Chitta in order to increase it. If the student answers correctly, the total positive mindset, the Chitta value of the student, will increase by 3. And the student will receive more questions that have a higher weightage towards the other 3 bases. This is because if the Chitta increases, in order to maintain the other 3 bases at an equal level, they will get more questions from the other side. As you can see, by balancing the questions in this manner, the system will try to maintain all 4 bases at equal levels. If I quickly conclude using a summary, a self-monitoring system has been developed based on the Buddhist philosophy of Irrithipada. It has 3 types of monitoring: Irrithipada-based monitoring, monitoring of emotions, and monitoring of activities. In terms of further works, it is necessary to further develop and train the system to gain a higher form of accuracy, and testing must also be carried out to evaluate the effectiveness of the system. These are my references. And in terms of acknowledgements, I must thank my supervisor, Dr. Gunathilake Hettige, without whom this project would not have been possible. I'm also thankful to all the lecturers of the Faculty of Computing for all their help. Thank you.
Okay, thank you, Silla. Thank you very much for your great contribution for the AI, especially this is novel area for the research. Okay, thank you very much, you and your supervisor. Also, I cordially invite our panel members. So they have valuable suggestions and comments. So I cordially invite them to join with this session. Yes, madam.
You have said that it's a further work to evaluate the system. So can you suggest a way that you're going to evaluate the model?
Yes, madam. So basically, I'll be carrying out the testing by using a classroom of students. And the students will be divided into 2 groups, and they'll be taught the same lesson. One group will be using the system. The other group will be taught the lesson without the system. So afterwards, the 2 groups will be given some quizzes. And if the group that used the system performs better than the other group, that means the system is effective.
That is the method that you are suggesting?
Yes.
Can I ask a question? This is from Zoom.
Okay, yes, sure.
Yeah. Now, I was a little confused how you map these questions to for Irrithipada. What's the relationship between now when you said Chitta, Vimansa, those things? How you map those questions?
Sir, in my presentation, I used to sample a lot of questions. In order to properly map it, we can, I was planning on consulting with my senior lecturers as well as maybe the clergy to decide what questions will help improve each of the 4 bases.
Yeah, because the example you showed, it is not measuring what you say. For example, let's say how we can measure Virya. After the lecture, and Vimansa, for example, to measure something, you may need to, Vimansa means you said that it's exploring further. If it is so, then you need to give a question that was not taught in the lecture, but related to something, and you need to further explore something like that. Is it?
Yes.
So that mapping is in your example, but the mapping, I don't think that you can achieve what you intended from those type of questions.
Sir, the questions shown in the slide were just as an example, but it's necessary to talk to senior lecturers in order to properly decide how to map the questions.
Yeah, then I think that's the major contribution that in your work. So it's a first step that I guess you should think more on that. Once you show those questions, who is the king of this, something like that, I think you can't really measure that quantity that you are trying to measure, I guess. Yeah, especially that I don't know what type of questions to set to measure some kind of aspect, chitta kind of aspect. I don't know. We need to think through. Maybe psychological aspects also need to be considered there. And what about the emotions? Are you considering the emotions during the lecture or at the end? Because there should be a way to measure it during the lecture, is it?
Yes, sir. It will be during the lecture. Every every 1 minute or 2 minutes, the picture of the student will be captured, and at that point, the emotion will be assessed.
From which features?
Sorry, sir.
From which features you are going to capture the emotions?
So basically, I'll be using TensorFlow, so it will take a
No,
picture.
no. Which features? For example, how you get whether he's sleepy or not?
The emotion classes that I'm concentrating on: happy, sad, surprise, and neutral. So I've trained the data set using those emotion
Using
classes.
images, can you?
Yes, using
Can you
those
do that?
sample images, and then the image that I take of the student will be compared to those classes.
Okay.
Okay, thank you.
Okay, thank you.
So any more questions?
One more question.
Yes.
So when you are taking that, when the evaluation comes, do you give a pre-questionnaire to the students and assess the level of emotions before starting the sessions, and to make sure that it has been increased by incorporating these aspects afterwards, being a post-evaluation as well?
Yes, madam. As soon as the system starts, the emotion will be monitored. So at the end, we can compare and see if the emotion has improved.
Okay. So emotional detection is based on the facial features?
Yes, based on the facial features.
Okay, thank you. Thank you very much, panel members. And especially Silla, please take all the comments positively. I think you can do good publication. So thank you very much. And we will move to second presenter. Second presenter is, thank you. Second presenter is Mr. Bandara. Mr. Bandara also from KDU product. He's a BSc Computer Science of General St. John Kotalawala University and currently working as a project and operational manager at AI team. So Mr. Bandara, please start your presentation.
Thank you, sir. Good evening, everyone. I'm RMVD Bandara, presenting today my research work on Sibil AI, the children's story generator in Sinhala using transformers. Myself, HA Sanja, B Hettige are the co-authors of this research. As you can see, this is the content which I'm about to update you guys on. Once upon a time in Sri Lanka, there was a researcher who wanted to do something along with the his most favorite author in his childhood, Sibil Hettige. Down the story memory lane, we all knew one thing. Most of the stories we have listened from our parents were from Sinhala. As per the researchers who have conducted how much of literature that using in Sri Lanka, Sinhala happens to be the most spoken language in Sri Lanka. And with this Sinhala and with the COVID-19 pandemic, along with the busy schedules of parents, the storytelling concept have been going away from the kids and from the parents away. And again, the natural language processing of Sinhala was in the uprising in the current decade, and researchers as well as the co-authors wanted to do something to contribute over it. Reading stories for the children in the early stage makes a significant improvement, enriching their vocabulary as well as language comprehension. Stories all about building the children's personality. As you can see, the research problem was there, since the story is playing a vital role in children's personality growth and amidst parents' busy schedule over their rat race, which is happening today over the world. They were missing the interaction time of storytelling, even in the bedtime or even in the evenings, in a holiday with their kids. That have affected children's subconscious in drastically. And personally, I have some first-hand experience along with one of my cousins, which quite a tragedy by today. To address this research problem, to build up the psychology, as well as we needed to find what kind of a solution that we need to give over this research problem. So when you were looking for the gap, there were no Sinhala story generator for Sinhala for kids. And then with the aiming of building a kid-centric story generator to build the personality as well as over supporting the parents, even amidst their busy schedules. They don't have time to go over there and find a storybook, but still they can use Sibil AI. Over the objectives, as you can see, Sinhala support generative and carrying out grammatically correct generations for the Sinhala generations, and related content for applicable for the children's mindset, and customizable prototype development according to the personal interest, which will be the input parameters for the models in previous slides, which I'm about to expect, and creating a model that encourages the creation characters in order to produce original tales with unique approach. So as you can see, these were one of my related works, which were the the work that conducted by the previous researchers of the generation in the last few years. By studying all these related work, what we saw was there was a plenty of opportunities to generate stories along with some kind of an centering set of age gap, but there was no best kind of an approach to do so. After we having thorough literature, we found out to do a set of age-centric or personality-centric generation over the text. There were two major approaches. After we conducting this qualitative research throughout the thorough understanding of literature, we found out Markov model is there, as well as Markov model, as well as the transformer model. Around 2020 or 2021 August, a set of Chinese researchers were able to find out a hybrid model, which is building transformers based on direct hidden Markov model for machine translation. Those models were not publicly accessible, so we were unable to reach out with that model. So we had to conduct two separate scenarios to find out what the model that is going to applicable for our use case. This neural hidden Markov model has been proposed an alternative to attention mechanism in machine translation with recurrent neural networks. However, since the introduction for the transform models were there, the performance of the HMM was surpassed in drastic manner. And this work proposed the concept of hidden Markov model to the transformer architecture, which outperformed the transformer baseline. That was the approach of the Chinese researchers. Okay, and when we were having the phase when we were assessing what model to move forward with, we took 10 tweets from politicians, and then we tried to recreate those tweets to see what kind of a regeneration it is happening along with these two models. These same process were carried out by another set of researchers as well. We followed their process, their steps to carry out this. And then we cleaned out the data set, and then we generated 5 tweets using separately from Markov and separately from GPT-2. As per the previous researchers, they have conducted to over 90 cycles, but we were unable to do the 90 cycles. We did for 30. And we know about the, after we doing some generations and we need to assess. So we thought the BERT score is the most effective way for us to assess the regeneration of this process. Because when we come to the BERT score is an automatic evaluation matrix using for testing the goodness of text generation systems, unlike the existing popular methods that compute token level syntax similarity. BERT score focuses on computing semantics similarity between tokens of reference and hypothesis. To validate this hypothesis, so we thought the BERT score is the most applicable approach to test. To evaluate the quality of the short story the system has generated, one can use existing systems such as ROG or BLUE matrix, depend on the syntax overlaps between the hypothesis and by the references. But considering the limitations of the ROG and BLUE, with the presence the exact word hypothesis and reference not being able to decode the semantics for the matter, we used to follow the BERT score. As you can see, we did the BERT score analysis same as the previous generators. This is from previous generators one. Warren Buffett, Joe Biden, and Kamala Harris were the 3 politicians that we took to test out this. 0 was the worst approach, and the 1 was the best approach that we can look up. As you can see, Markov, they have produced mostly near around 3.4, 3.2, and 3.95. But when it's come to GPT with the 90 runs, they have scored more accurate levels than the Markov. So we thought of, okay, let's move forward with the GPT. And since GPT is based on transformers, since GPT is based on transformers, we thought let's focus on how the transformer works. If you look at the transformer model, the encoder, it's an encoder-decoder architecture, which is happening through sequential data processing and allows for much more parallel data transitions as well as training than RNNs, which are happening today. And GPT especially supports training times in drastic reducing manner. If you look at the architecture of the this GPT model, you can see it's a feed-forward neural network which is going through a separate set of nodes before we come to the meeting of softmax. The reason why we took this pre-trained GPT-2 model was it was already pre-trained for all the texts, any kind of a text, any variance of the text for 1.5 billion parameters throughout this internet, which are we surfing today. So this GPT-2 doesn't need to sequentially process the data because it's already been trained for almost 1.5 billion parameters. So this is the same architecture as I was explained earlier. Yeah. So after each token is produced, that token is added to the sequence of inputs. We did a sequential thing because we needed to make sure the children-centric inputs were getting applicable correctly. And the sequence became the input model to the next step and so on till we get the output token. We did the sequential run. And if you look at the overall process architecture, as you can see, user inputting their favorite keywords and then forwarding with the Gradio and then to come to the model. to find out what kind of a story that they are facing. This is the data set 1, which was the Facebook data set. We remove this data set from using because this contains some kind of an bad words as well as some racist words. So we took it out because this is children-centric. And the data set 2, this is a combined data set by a fellow researcher. We use this because this contain set of extracted children's stories, which is in English. And this is data set 3. We didn't use the Shakespeare story data set because the words that carrying out in this data set were too heavy for a kid. And along with this, we fine-tune the model to find out what kind of a set of characters and what kind of set of input parameters that we need to set up. And then we got these results. We found out king, the Rajuruo, prince, Kumaraya, Kiri, milk, cat, Pusa, dog, Balla. We found out those type of words are the words that generating more much kind of a kid-centric stories rather than other words that we found out within the 30 cycles that we run on. And for these results, we did again a bird score analysis with one of my fellow researchers, and we found out these are the best things that we can move forward with along. The reason why we did it in, if I go back to the architecture, the reason why we did in English was we were unable to set up the enough data set in Sinhala, because as we can, Janaki Suryarachi, Sibil Singha were the two prominent kid-centric story writers, but altogether all of their research, all of their books are not enough to conduct this kind of a research. So we had to go with English, and then we had to training it in Sinhala. So the limitations were, as I mentioned, and the most prominent model, GPT-3, was not applicable, accessible for the public usage. For we applied for the fellow research queue. Now we are waiting to get the access on it. So the further work will be conducting through the GPT model 3 when we get the access to add-on. And these were my references. Thank you so much. Thank you for this KDU IRC committee for organizing this event, as well as for Dr. Buddhita, as well as the Ilmini madam for supporting me all the way for this research. Thank you so much. Have a good day.
Okay, thank you, Bandara. Thank you very much for your presentation. First, I will move to the panel members. I know they have a lot of suggestions.
I would like to ask what kind of evaluation methods that you can follow once you generate these stories, how you are going to evaluate the quality, because you are going to give it to students, maybe, so the children. So how you are going to evaluate the goodness of the generated stories?
For the initial phases, we did was we get the, again, pre-trained bird model, and then we run it through the stories that we generated. And we gave the parameters as these words need to be in here, and see how well these stories have been generated in semantic manner. And that's the base model that we had to evaluate. And then again, for the quality of the kids, we are like yet to conduct that assessment. So we took 15 of my cousins who are young parents at the moment to evaluate set of stories that we are giving to them, and taking some kind of an input from them, how well this is applicable for their kids. So that was the approach.
What is the output of this research, that is that you are allowing the children to read these stories or someone to narrate them? What is
Both features have been already developed and applied.
Okay.
Narration as well as the reading in
Okay.
English, both in Sinhala as well.
Okay, thank you. Thank you, madam.
I have a question in case number 2 and 1, where you have given, in the paper, when you translate it, it's not exactly the meaning that is being translated. The English translate, when you get the original one in English and when you translate it into Sinhala, it's not the exact one.
Yes.
So do you intend to give this as it is? So is it going to be modified by a human person, a third person, before delivering it to the
kids?
Kids.
Yeah. Before delivering to the kids, human interaction is there to fine tune this. Actually, these days we are focusing on how well we can do semantic similarity translation to Sinhala. We are developing another model for that as well. But at this moment, human interaction is there.
human interaction.
Yeah,
will be
without that
there.
we can't do.
So, I mean, with your model, were you able to generate any new cases? Totally new cases.
Total new. It's like we were unable to generate a new. Anyway, it's some kind of a story we have heard any place in the earth at the end of the day. Because like even a new cases that we found, we thought they were new, and then again when we were like looking whether this is a new, it was not a new. It was anyway, at least even a similarity case was there.
Yeah. So once, I mean, the presentation you were telling about that you took some narrations from
Yeah.
politicians and tried to create some
Yes.
cases.
Yeah.
So what is the output of those cases?
We did the politician tweet understanding to find out what model that we need to applicable for this research. So we ran with Markov, and again we ran with GPT in the same time. But later again in 2021, a set of researchers have found out a way to directly access transformers from direct hidden Markov model.
Okay, so in that case, you are handling two different scenarios.
Yes.
So is it all right to apply the results obtained from one scenario to the other scenario in a one-to-one manner?
Yeah. For that, what we did was we needed to find out what kind of an approach that we can do for the next step of the next word generation. So that's what the planning was to have. So in that case, for the tweets was the easiest way, because we can see previous tweets and the tweets then generated how similar these two are. So at the end of this research, in the future aspects, our goal is to generate Sibil Hettige stories even after her death for another 100 years. So we want to replicate exact same writing pattern. So that this is the base line of the project, that we are looking to hit the moon at that kind of a level. So so for that only we tried to find out what kind of a model that we need to carry out forward. That's why we took the tweets thing.
Okay, thank you. And any suggestions from the audience? Fernando, so I know definitely you have some suggestions for this. Okay.
My question is, so how do you embed the creativeness in the system?
Creativeness is totally based on the data set that we are providing at the moment. So how well those input data set stories have been inputted.
Can these models capture these creativeness to the?
At the moment, it can't. Sir. It can't understand what kind of a creativity level it's there. We are like focusing on fine tuning for this GPT-2 model to find out the creativity, but it's quite hard to do with GPT-2 at the moment. So that's why we have like applied for the access of GPT-3, because in that the reason why it's not giving to the general public was it was access for the general public. One of the students have used GPT-3 model to do all his homework, the university assignments, and then the lecturer caught it, and then they applied to not to give it to the general public. So that kind of a human faking level is there in the GPT-3 with the creativity. So we are waiting for that model to continue with the creativity, sir. At this moment, we can't do that, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir. And any question from the audience? So
Can
okay,
I
yes,
ask a question? Yeah.
Yes, sure.
Yeah. Now, now this is apart from the translation. The harder problem is that you said that, for example, Sibil Hettige's writing pattern, taking that into this context. What can we do for that? I don't know. That's for my understanding. Is there a way that we can approach this problem?
Yeah. As per the transformers, if you saw the previous slides, how well the tweets from the politicians have been recreated and how kind of a similarity between the previous tweets as well as the newly generated tweets. So that will be the same approach that we're going to replicate to find out how well we not to find out, to generate the same energetic similarity between Sibil Hettige's original stories as well as the new stories. But unfortunately, at this moment, we don't have pure validation to validate
Yeah.
whether Sibil Singh's writing style or not, but still with her previous books, we can evaluate her context. So the same approach will be taken to recreate the similarity. Yeah.
So that means maybe in your model, you need to have some component to learn her writing pattern also. Is it?
Yeah. Yes. We need that too for the Sri Lankan authors.
Yeah. So it will be a very hard problem to hit, I think. But it will be good if you can achieve that, I think.
It just matter of having the total data set. After that, we can like fine tune the model. It's just matter of
Okay.
having the data.
So ultimately, after conversion, how we can guarantee the accuracy?
Because we're assessing the model, right?
Yeah,
Yes.
how we can assess the model?
We can use the same way as the bird score, but to find out the similarity and to the quality, we can like get the.
So can we guarantee upon this performance metric entirely? Is it possible?
At the moment, yes, we can.
So from your previous evaluations, you can fully guarantee on this metric.
Yeah, up to the level that we have found out, yes.
Okay, because this product is for children. Again, it should be perfect. If you cross maybe misplace one or two words, the sentence meaning will go away. Yeah. And that sort of things are there, but I don't know, maybe that's the critical point here. Okay, and it's good, the intentions are good and project is good here.
We actually faced that issue. That's why we removed the Facebook dataset. When we tried to generate with the stories in the Facebook dataset, there were some racist and not Sri Lankan cultured words were there. So we removed the whole dataset.
One other thing is that tweets from politicians, they are little complicated and sort of biased to a certain domain. And tweets are like, maybe tweets are not exactly in the storytelling format. They are like informative. Maybe you can try with in storytelling nature context also. Yeah. So that maybe your model that you have chosen for this work may be different when it comes to storytelling, because the word set is relatively less complex.
Yes, it is relatively less complex, but if you look at their tweets, the reason why we pick those politicians was their tweets are much like storytelling. Even when they are throwing mud at each other, it's much like they are like telling in a manner. That's why.
Okay, then it's good. Okay, thank you very much. Yeah.
So much.
Okay, thank you, Dr. Amiru. Thank you very much for your great support. Okay, so next we will move to next presenter, another product from the KDU, Miss Nimesha. Nimesha is following BSc Information Technology degree program at Faculty of Computing of General Sri John Kotalala Defence University. Currently, she is doing her internship at Virtusa. So, Miss Nimesha, please start your presentation. Okay, Nimesha.
I'm GHGI Nimesha, and my research article is Multilingual Learning Platform for Kids to Learn Foreign Languages in Sri Lanka. When we talk about the introduction, learning and teaching a foreign language is not easy, and the researchers have said that it is not challenging if it is practiced from childhood. So the main aim of this is to achieve the initial steps when developing a foreign language learning tool for kids. And also this research paper mainly considers the best age range for students to learn the languages and also the ideas of parents and teachers about the tool. Here are some of the literature review that I have taken in the research paper. Some of the main ideas are chatbots to practice the language, computer-assisted pronunciation instruction, automated voice recognition, how tools may be better integrated to provide a more productive working environment for language learners, how language learning strategy can support children within the first stage of the language learning process, using bots in the language education with practical scenarios, recommendation on how to use the modern technologies as a motivational factor for foreign language learning, multimedia storytelling web application, and linguistic stressor and performance are some of the main areas of the literature review that I have focused. When we talk about the methodology, a survey was conducted to collect the data, and it was distributed among 150 people and got 94 responses. There are three main user roles as students, parents, and educators. When we talk about the analysis, this figure shows the age limits of the kids. And in here, more than 80% of the parents mentioned that they do not, their kids do not follow any foreign language at the moment. And rest 20% of the kids are learning at least one foreign language at the moment. And here this figure shows the languages that the kids are learning. 60% of the kids learn French at the moment, and another 20% are learning Japanese and Tamil respectively. And among them, 60% of the total number of kids have learned the language for more than a year, and 40% have learned for 2 to 5 years. And more than 90% of the parents would like to teach foreign languages to their kids, and their recommendations to the recommended languages to included in the tool are French, German, Spanish, Hindi, Chinese, and Japanese. The parents' options to teach foreign language to kids who do not follow any languages are shown in the diagram. They have chosen private classes, YouTube, and online learning application. More than 40% of the parents selected private classes to attend their kids, and others have selected another tools and YouTube and another materials to teach for their kids. And this figure shows the age limits of the students. 78% of the students are from 21 to 25 years, and the rest are 10 to 15 and 16 to 20 years. In the student category, it mainly focused on the high school, middle school, and undergraduates. 55% of in the ages of 10 to 25 have not studied any foreign languages and would like to learn the new languages. And the rest, 44%, 6 of the students have learned any of the foreign languages. And here, these are the analysis of the educators. These are the figure shows the subjects that are taught by the educators. There are Japanese, French, English, Hindi, and Chinese. More than 60% of the educators teach foreign languages for any age group, and others teach for kids and school children from 4 to 19 years. And the figure indicates the teaching experience of the teachers who have participated in the survey. 91.7% of the teachers recommend using the foreign language learning tool for kids to enhance their language. This slide shows the opinion of the teachers who are teaching foreign languages. 71% of the teachers state that the student use native languages when answering questions and when communicating. Most of the students are enthusiastic about the learning and quickly understanding and getting used to the language easily at a young age. And some students get bored and are not interested to learn the language. Some students don't concentrate on the lessons and lack of reference book with native language explanations. These are the difficulties when learning foreign languages: finding suitable classes, limited number of courses, high tuition fee, no time to learn a new language, unable to understand and use the language properly. These are the suggestions to be included in the language learning tool. Categorize the activities and lessons according to the age or from beginner to advanced steps. Activities to make lessons understand easier, attractive and user-friendly, include pictures, videos, and animations. Option to practice letters, numbers, grammar, and pronunciations using a flashcards, quizzes, puzzles, and games. For the future work, I'm going to design and develop a mobile application that is helped to learn the language step by step from the beginning. This includes the basic areas of the language which can be used by any age range, and it facilitates the study of the language basics, vocabulary, grammar, spellings, tenses, and pronunciations in the language. These are the references that I have used. Thank you.
You. Now, presentation open for the audience, the first panel members.
So I think the system is not yet implemented, right? So do you have any idea about what kind of age group that you're going to target from the application?
For kids actually, and also it can be used for any age range because it facilitates the big levels as beginner to advanced. So there's no age group, actually anyone can use it.
But I guess you have to mention an age group. I mean,
Yeah, I have done the survey for different age groups. So
maybe let's say like 5 to 10 years or some kind of.
Yeah, I have given the survey for different age groups to get the ideas about the likelihood of.
Have you selected any language, specific language for the application?
Currently, I'm using French.
That's what you're going to implement?
Yeah.
Okay, thank you.
Yes, madam. Any more suggestions?
So, I mean, when you are trying to implement French language as a learning tool over here, so have you thought of integrating what aspects? Have you taken care of pedagogical aspects as well? Because learning, when it comes to learning, you just can't copy something and give it back to students because it has to be going through a curriculum kind of a thing. So you have to think about the pedagogy and everything. So have you thought about that aspects as well, or is it just a kind of a conversion from English to French or something like that?
No, that's not a conversion of English to French. It's basically there are different. It has steps. For example, if someone know the little about of French, they can first go to the quiz and answer the questions. And if he think that he can understand some part, then he can move on with the next steps. There are some quizzes, so we can answer questions to get an idea whether he knows the language or not.
Okay, so in that context, your scope is vast because when it comes to teaching a language, it's a huge, breadth-wise, it is a huge one, and there are so many syntax, semantics, and all the language rules.
Yeah.
So do you have a kind of a scope you have defined?
For the initial steps, I have only developed, I'm going to only develop for certain level.
So better think because you sometimes it may be teaching adjectives or something like that, even within the age limit, as Dr. Anuradha said. So you have to clarify it into, limit it into an age limit and a specific language component maybe. Otherwise, within the stipulated time period, it will be too much and you will not be able to achieve your objectives.
Thank you.
Thank you. Thank you. And now open for the audience, especially online platform, Dr. Samaru. Any questions from audience? Especially we know most of them are undergraduates. I know they have a lot of questions, especially next year they are going to present like this. So please because most of the senior panel members, they gave many suggestions, especially from young members. So if I know you have some suggestions, questions, okay, from the audience, please. Okay, no question from the audience. I have one question. Nimesha, how about the data sample?
So I have not not started the implementation.
This is just like a concept.
Yeah.
Okay, so please, because concept is not enough actually. So better to find a
I'm
good.
going to present it for my final year research.
Okay, okay, very good. So the next time, better to go find a good sample, do the validation. So I hope you can do a good presentation, good research publication. Okay, thank you. Okay, thank you. Okay, so we will move to the last presentation. Miss Gunathilake. Miss Gunathilake also from the KDU. She is following a BSc Computer Science degree program at Faculty of Computing of General Sri John Kotalawala University. Currently, she is doing her internship in SimTech technologies. Okay, so Miss Gunathilake, this is time for you.
Thank you, everyone. Good afternoon, everyone. I'm Gunathilake. My research is emotion recognition for autism spectrum disorder using deep learning, and my supervisor is Miss GHGI Uwanthika. So this is the content. The autism spectrum disorder is a neurological disorder. So this disorder may affect the brain structure and function, which may lead to the following symptoms like social impairment, communication impairment, rigidness in thinking, language, and behavior. So there is no cure for these disorders, but using treatments, we can manage and improve the symptoms. Children who are suffering from ASD must follow courses of speech therapy, occupational therapy, and psychological and educational services. If we talk about ASD in our country, among the 93 children, only one child can be diagnosed as an autistic child. And for the diagnosis process, there is no standardized ASD diagnostic tool in our country. And they use like a autistic diagnostic observation schedule. But there are very few number of professionals who are certified in this certified to conduct this ADOS2 in our country. Also, when we talk about the speech therapy, approximately there will be like 151 speech therapy pathologists in our country. Which means that there can be one speech language pathologist for every 135,000 citizens. It's a huge amount. So developing this kind of tool is very essential for the autistic children to follow their courses regularly. So when we go to the related works in this area, so in the first research, they developed a game, Emotify, to identify the emotions using a random forest classifier. And in the second, research, that researchers developed a deep learning-based evaluation system to identify the articulation disorder and then provide the learning management system using a deep neural network. In the third research, they also focusing about identify the emotion using speech emotion recognition using support vector machine. They're able to get like satisfied accuracy. And in the fourth research, they developed a framework to identify the speech abnormalities related to the autism. In the fifth research, they focus about identifying the speech emotion and it is developed for the Sinhala language using a convolutional neural network. In the six research, they developed a framework to identify the disorders in language disorders using LENA recordings with the help of support vector machine. Next, they developed educational emotional games to identify the emotions correctly using automatic speech recognition. For the features, they use tempo, pitch, and volume. Then using those features, they check whether that particular child is able to identify the mentioned emotion correctly or not. This 8 research is very special one. So they used 2 machine learning models. They get the speech recording of the child, and then using a first machine learning model, they classify the utterance. And then after the second machine learning model, they recognize the pattern. In the ninth research, they focus about estimating the autism severity using their speech recordings with the help of deep neural network. And the last, it's again a special kind of research because they use cognitive computing for identifying the disabilities of the child using a convolutional neural network and as well as the recurrent neural network. So the gap I found out in this research related works, they only focusing about identifying only the impairment, but they are not providing a methodology to overcome this impairment. And as well as another thing that as some of the researchers' accuracy is not satisfied enough. I think it's happened because of the lack of data. So after considering those gaps in these related works, so I come up with the solution. In our solution, when we talk about the methodology, the first thing we must talk about the data set. So first we thought to develop this for the Sinhala language, but unfortunately, due to the lack of data resources in our country, we hope to develop it for the English language. Therefore, we took the online available data set, which is RAW-DAYS and the Toronto Emotional Speech Set, which is TEST. So in the RAW-DAYS data set, it contained like 1,440 audio files. And also it contains the emotions like calm, happy, sad, angry, fearful, surprised, and disgust expressions. All the audio files are in the .wav format. In the test data sample also, it contains like 2,800 data files in the WAV format. Before feeding these data set into machine learning model, we have to do pre-processing and the feature extraction. That's the first step of our methodology. So for the pre-processing, we use data augmentation methods such as noise injection and the change in the pitch of the data. So here I have upload a sample video from the test data set. It's a fear emotion video audio. So just give me 1 minute.
Say the word youth.
So it's a sample audio. So it's for the fear emotion. So before pre-processing, it will be like that. Okay. So then
say the word youth.
After performing the noise injection, so the recording will be
say the word youth.
Now you can see, you can hear like sir background noises from that recording. And after performing the pitch for that audio, so it will be
Say the word youth.
like this. So this is how we did the pre-processing for the each of the data file. And after pre-processing, the main objective of pre-processing is to make our model resistant to these perturbation and increase its generalizability. And after performing the feature extract pre-processing, then we focus about the feature extraction, because we have to get very important information from each recording. So therefore we focused about feature extraction. So we extracted features like zero crossing rate, trauma STFT, MELC frequency septal coefficient, root mean square value, and MEL spectrogram. For the feature extraction, we used Python librosa library. And at the last step, so the classification. So for the classification, we used recurrent neural network model, which is very effective for long sequence data or natural language. And this neural network is a fully connected 4-layer neural network. It can classify the recordings into 7 categories, which I mentioned earlier in the dataset part: anger, disgust, fear, happiness, neutral, sad, and surprise. We also added 2 long short-term memory layers for the first layer and the first hidden layer. For the 2 hidden layers, it consists of like 128 neurons, and 1 layer used ReLU activation function. For the output layer, so it has to categorize the emotion into 7 categories. So we use 7 neurons for the output layer, and with the help of softmax activation function. For the optimization of the machine learning model, we use Adam optimizer. So in this graph, you can see the accuracy of the MA model. So finally, as the results, we can be able to get like 91% accuracy with the 0.25 loss percentage after 50 pointers. In the discussion section, I wanted to mention that we apply the rounded dataset to the RNN model, but unfortunately, the accuracy is not satisfied. Then we applied that same dataset to the CNN model. Even the accuracy also again decreased. So therefore, I think this problem arose because of the amount of the data corpus. And then we focused about the test dataset and RNN as our MA model. This system is especially, I want to mention that this system can be used to the children, autistic children who can verbally communicate. In the conclusion, I want to mention that developing this kind of tool is very essential for our country, because we're using some old mechanism to diagonization process. So if we use this, then we can do the fast diagonization. And also, if we can train this model using more data to identify the other emotions as well, so it will be efficient. So as the future work, I hope to add another feature to identify the articulation disorder of the autistic children like Babber-Egoism and Equalia using a convolutional neural network, and then develop the speech recognition based speech therapy system to give the speech therapy in very interactive manner. These are the references of this research. And finally, I will take this opportunity to express my gratitude to my following professionals. First, I would like to express my appreciation to my academic supervisor, Ms. GAI Uwanthika, who was a great role model throughout the course of this project. Her advice and guidance allow me to perform to my fullest potential. Second, I would like to thank Dr. Manti Disanayake, who is the speech language pathologist, helped me with the questionnaire to get an idea about the ASD children's behavior and language capability. Finally, I would like to thank everyone who has assisted me and has always been at my side. So that's the end of my presentation. Thank you. Thank you very much.
Thank you, Gunathilake. Now presentation open for the panel.
few concerns. First thing is that the audio that you played, it's not a sound of a kid, I guess. So your data set is from some adults. So after training with that data set, how can you assure that it will work for the kids properly?
Actually, we thought of developing this system for the children, but first I mentioned because of lack of data set in our country, we took online available data set, so it contains adult voices, and so I think with training we can overcome this issue.
Have you tried after training and you have obtained some accuracy?
Yeah.
So after that, have you tried the model with real data?
Yeah, I have tried uploading my own.
You're not a kid, no?
No,
That's
yeah,
a
yeah, I
problem.
know that's a concern. So I have uploaded some other recordings as well, but sometimes the accuracy decrease, not satisfied. So
Yeah.
we have to consider about that part also. And
Data
it's
set
really-
must be more appropriate one, otherwise you can't claim that it works, right?
Yeah.
Because for the kids, they are the way they talk, the way they put their anger, happiness is totally different from the adults. So you
Yeah.
have to use a proper data set, I guess, when
Yeah,
you're
okay.
going to do the further modification.
Thank you.
I have some few questions with regard to the same. So when you take the foreign data sets,
Yeah.
their accent and pronunciation, the way they pronunciation is much different than us.
Yeah.
So I think around this Moroto area, there are a few places where these children are over there. So I mean,
Yeah.
I would like to suggest you to go and do some, if possible, do some recordings and see and benchmark. I mean, you can benchmark your system with other things, but you can use this as a case study to see how it will fit into your local context. So that will be really good because I mean, we are trying to train models with foreign data,
Yeah.
but when it comes to our local context, they do not map one-to-one. So we need to try with our own data as well. So if you can build up a little bit of data with that, that would be good. And the other thing is how you have managed. I mean, so have you? I mean, only with the speech you identify the emotions.
Yeah.
Okay, so I mean, is it proven that with speech they express all their emotions, they do not hide the autism children?
Yeah, they are hiding that. So we are developing this one. So when they are, for example, so now if the child want to say something in happy mood, so after the diagonization process, I mean through the model, it will output the results as in angry mood. So I think there is a problem. So they here that child maybe have to have a problem with emotion expression. So we have to do certain therapies for that. That's how this is going to work.
Okay, so you are giving these are the emotional status of the child.
Yeah.
And afterwards, it is to some human to take care of.
Yeah.
Okay,
Thank you, madam. And from the
yeah, maybe one question on in your experiment, the data set, is it from people who have autism? Is it?
Sorry.
Because now we are going to recognize these emotions for autism spectrum disorder.
Yeah.
So your data set is from those patients?
No, actually, that's happened because of the lack of data resources online as well as in our country. So we
Yeah.
took,
So at the moment, what's happening is you are trying to recognize the emotion from the audio clip.
yeah.
So there's no relation to autism.
Yeah, so we
So what
currently
it's
suffering from ASD actually.
yeah. So you can't say now whether there's a possibility of autism or not based on these results, is it?
Yes.
Yeah. So actually this paper should be speech recognition, emotion recognition only, not for autism spectrum disorder, because there's no research part for that, I guess. Is it?
So, yes, I think because it's happened because of the lack of data issue case, I think, because at the beginning we contacted like 3 places to collect the data set. So the thing they told us is that they don't have a fluent data set for the
Yeah, maybe when you are publishing, I think better to change the topic, because in the paper there's nothing related to autism.
Yeah, okay.
Yeah, totally different things. Emotion recognition from speech is somewhat well-studied area. So what you're doing is classification to these different emotions, I guess. Okay, but I think it will be really difficult to find this data set, I guess. So anyway, if you can do that, that will be good, since you now have experience of handling this data set. If you can find the data set, I believe that you can exactly apply some of the techniques that you learned, but maybe better to remove that part from the title of the paper, maybe when you're publishing it with all this work.
Okay,
Yeah,
so
thank you. Thank you very much. Yeah, just a suggestion. Okay.
Yeah, I know.
Yeah.
Thank you, Dr. Samiru. And from the audience? Okay, thank you. Actually, during this session, we did 4 presentations.
Thank you.
Especially, okay, thank you. Especially first one, the Sinhala, she did self-motivation system for online education. Okay, so Sinhala, if you want to go for the publication, please find, especially I didn't see any validation part of your research, so better to do a validation. Mr. Bandara, especially children's story generated in Sinhala using transformers. Yes, very good research. Especially, I think better to add some validation part for your research also. It's good. And Miss Nimesha, yes, as she mentioned, this is a very just like a concept paper. So I hope you can do well, especially after finding good data sample and the better do a validation. Okay. And the last presenter, Miss Gunathilake, yes. So as Dr. Samir said, so discuss with your supervisor, especially if you want to add autism part for your research, better to find the data set as Kala Madam also said. Okay, so thank you. Anyway, I know during the COVID and the economic crisis, there are so many issues to find the data samples. So, but anyway, as I mentioned earlier, we need to thank KDU continuously organizing this conference during the COVID as well as economic crisis also. So anyway, just one suggestion as an outside member. So this session just only we did with all the papers from the KDU. So especially as an international conference, better to find more papers from the outside. I think it's more better for the session. And also, I need to thank my panel members, Dr. Anuradha, thank you very much. And Mekala Madam, thank you very much for your great support, as well as Dr. Samiru from the online platform. Thank you very much. And thank you very much for your great support as well as suggestions for our undergraduate students. Thank you very much. Thank you very much, audience.
Thank you, sir. Ladies and gentlemen, now we have come to the end of the Computing Technical Parallel Session 3. Now, I would like to invite Professor RMVD Rathnayake, the chair of the session, to present certificates to the presenters. You may come forward as I read out the names. Shilanti De Silva, RMVD Bandara, GHGI Nimesha, and MD Gunathilake. Sir, please remain on stage. Now I would like to invite Mrs. D.U. Vidhanagama, the head, Department of Computational Mathematics, Faculty of Computing, to present the token of appreciation to the chairperson. Thank you, madam. Thank you, madam. On behalf of the organizing committee, I would like to extend our gratitude to Professor RMKT Rathnayake for chairing the Computing Technical Parallel Session 3. And with this, we conclude this session, and I cordially invite all of you for refreshments outside. Ladies and gentlemen, please be present here at 3 p.m. for the Technical Parallel Session 4 on the theme of Enhancing the Digital Transformation through Emerging Technologies. Thank you and have a pleasant evening.